Okay, here's a bit of an overview of exercise 5.7, the ones we did in class, just so you can get a second look at it. So in question 1a, we've got y equals 2 over x. Now we know the general shape of a hyperbola, but what does the 2 do? Well, the normal one, if I can just get a green pen, the normal y equals 1 over x. If x is 1, it'd be 1. So it'd actually come in there. Let me just fix that up there. It'd come in here at 1, 1. So you can see that at 1 it's gone up to 2. Okay, so it's pushed your hyperbola out. So when you draw these things, you need a frame of reference so everyone knows the scale of your diagram so we can tell where it is. Otherwise you wouldn't be able to tell the difference between y equals 1 over x and y equals 2 over x. So I've actually planted a point on there, and the point that I chose was 1, 2, just so I've got some reference on the scale. They also want to know what the domain is. Well, the domain is all real x except x is 0. So here's your domain, because x cannot be 0. In fact, y cannot be 0 either, and there's your range. So you notice we have what's called asymptotic behaviour, and it's the asymptotes, the lines to which we are approaching but can never reach, are both axes. Now the x-axis is called y equals 0, and the y-axis is called x equals 0. So 1b, y equals minus 1 over x. Yes, we did do it in the quiz, but because this is now looking online, I'll quickly draw it. So we know that y equals 1 over x has that general shape. So if I'm going to make everything that's in that shape negative, see all these positives, they now become the negative. And see all these negatives, a negative is a positive, so they all become a positive. Let's just put a reference point. So if x is 1, y is minus 1, and that, if my diagram's not the best there, but that should work for 1 minus 1. Okay, now my diagram should really show the axes and the fact that these lines go forever. So I should put little arrows on them. Domain and range are the same. Let's look at C. So we now have f of x equals 1 over x plus 1. So we have a shift. Let's just look at that very carefully. I'll pick the pink one. See here? It's not 1 over x, it's 1 over x plus 1. So what does that do? It means that I've shifted along the x-axis. And how do I know what the shift is? The shift is always given to you by considering x minus some number, and whatever that number is will be my shift where I go. So how do I write x plus 1 in terms of x minus something? Well, that's x minus 1. So there's my shift. So long as it's x minus something, I know what my shift is. So that tells me that I'm going to move my graph left over to minus 1. I'm not shifting on the y, there's no shift on the y, there's only a shift on the x. So this is a slide to the left, down to minus 1. So I'm going to pick up my graph and move it across. Now how do I figure out this value here? Here is where I worked it out. We know that a y-intercept is obtained by putting x equals 0 in. How do we know that? Well, here's x. Show me where x equals 0. Right there. Right? X is 0 at that point there. So we can see that on that curve, that lines up with where it crosses on the y-axis. So I'm going to put x equals 0 in here. And if I do that, I end up with y equals 1. So that gives me my y-intercept right there. Our domain, well, x can be any real number except for minus 1. And the range, all real y except 0. Let's look at part D. We've got a shift. So the shift here, I'm just being consistent in colouring. The shift here, if I write that as x minus some number, what is the number? 2. So that means I'm going to pick the whole thing up and move it over to 2. And if we use that same process we did before, we'll put x equals 0 into the equation to figure out the y-intercept. If I put it in, it's minus 3 on 2. So you might well ask, well, what did the 3, see this 3 up here, what did it do to anything? It actually has changed the scale. If that 3 wasn't there, we wouldn't be cutting at minus 3 on 2, we'd be cutting at minus 1 on 2. So it's pushed it out. It's not minus a half, it's minus 1.5, which is here. Okay, let's look at E. So on this particular example, because I teach it to you in terms of shifting functions, I'm going to get you to try and get x minus something in there. I'm looking at that and I can see that if I factorise the denominator, in other words, pull a 3 out, I can find the shift. There it is. So you might say, well, what's that 3 doing? Okay, well, like in the previous example where we had a number on the top 3, this time we're going to have a number on the top of 1/3, which is the same thing. See that 1/3? I could easily put it on the top. Same thing. Because dividing by 3 is the same thing as timesing by 1/3. So I only did that so that you can realise that it's basically just a scaling factor. So all my y values are now 1/3 what they would have been if that 3 wasn't there. So that comes into play here. See on your y-intercept, if that 3 wasn't there, I would have had half. But because the 3 is there, it's going to be 1/3, which is 1/6. So that gives me that number there. And sure, we know about the shifting, and that's why it's gone over to minus 2. So what's your domain? Or real x except minus 2, and your range or real y except 0. So with f, what we had to draw was this one, y equals, oh no, that's not what we had to draw. What did we have to draw? We had to draw the reverse of that. I haven't written it down here. Here we go. What we had to draw was, I'll just write it in red, y equals minus 2 over x minus 3. When I say build it in stages, I do that because while we're still learning it, we can't do all these things in our head. So at the moment, I'm going to get you to draw it without the minus sign. So see this minus sign here? We're going to ignore that first, okay? So let's draw it as if there's no minus sign. That's what I've done there. So it's a shift of 3. Move it over to 3. The 2 is a scaling factor, so that just makes a difference here. See that 2 there? That's going to change where I cut on the y-axis. There's my y-axis, and it cuts there. I'm indicating it here. So we've got it drawn. Now the next thing to do is, well, I've written here, I want the negative of it, so I'm going to flip it. Well, if anything was positive before, it now becomes negative. So if I move that across, you can see all the positives now become negative and all the negatives all become positive. Is that okay? Right, now let's move on. The next one, I have a look what we've got there. So I factorised the bottom line first and then cancelled the 6 with the 2, and that leaves me 1 on the top and 3 on the bottom. Just take a minute and see whether you understand why I can, when I pull 6 out of 3, see this was the number I had there, why does that leave 3 over 6 behind when I factorise it? Well, think about it. 6 times something gives you, what am I doing there? 6 times something gives you 3. So what has that got to be? Well, I want a 3 and I don't want a 6. See how that works? So 3 over 6 is the same as a half. So that's how I got the half down the bottom there, and now that means I can read off my shift nice and easily. So that is there. So I move the whole thing across. The 3 on the bottom just means a scaling of a 1/3. So that's going to affect where I cut here. And you can see I've figured that out, the y-intercept. So what's my domain? All real x except x equals a half. And what's my range? All real y except 0. Now in part 2 they said we've got to show that f of x is odd. So here I've highlighted the definition. Let me just get rid of these yellow bits if I can, so that I can use that a bit better when I explain it. So this is my definition right here. This is what it is for an odd function. Odd functions, remember, have the negative value for the negative x. So let's just talk about what that means. So on this diagram over here, see x? There it is. There's its f of x, right there. Now let's go to minus x. What's its f of x? It's actually the negative version of f of x. See that height there? Exactly the same as that height there, but in the negative sense. So what we're saying is if I go to the function at minus x, if I go to want the function at minus x, I'm actually going to have just the negative of the function at x, which is that indicated by this little height here. I think my pen seemed to rub that out. Okay, so that's what's going on with an odd function, and specifically for this one. So they've given us this particular one, and we've got to show that it's odd. So I'm going to follow that definition. I'm going to put minus x into that function and see what happens. So see this minus x? Let's put it into the function. Well, the function says that you put x in there. Well, my x this time is negative x, so let's put it in there. Well, that's exactly the same as having negative 2 over x, which is the same as negative the function. So see that this f of x here, there it is, and I've just done the negative of it. So I've actually shown that it is odd because I've shown that when I put minus x in, I get the negative of when I put x in. So that makes it an odd function. And that's it for this session.